All right, so our lesson for today is going to be an introduction to working with percent. Okay, this is going to lead us into some tougher word problems, some context problems. They'll get us back thinking about terms, coefficients, and constants like we had yesterday in class. This is kind of a lead-in introduction lesson that'll set us up for success on day 2 with those word problems. So talking about percent, we have some little notes at the top that are important. So percents are always out of 100. Okay, so an example, 25% means 25 out of our total of 100. A percent can be changed to a decimal. Since it's always out of 100, you could take that percent, remove the percent sign, and put it over 100, and then or change that down to a decimal. Or the other method is if we had 25%, our decimal place started at the end here, so we find our decimal place, and changing that to a decimal, dividing by 100 is the same as moving your decimal place 2 places back to the left. Okay, so 25% is the same thing as 0.25. Okay, so in tomorrow's lesson, we're going to have percents involved pretty heavily, where we're having to take a real world context, translate that context into an expression that involves percents, and then simplify and talk about terms, coefficients, and constants. So in order to get there, we have to be really good at finding percents. Okay, so we're going to start here. Okay, so like number 1, it says find 20% of 50. Well, we have an important note up here at the top. Okay, notice there's even a star next to it. Percents are always of something, which means a percent isn't a percent unless we are multiplying. Okay, so what do we mean by that? We mean if we're trying to find 20% of 50, well, we're going to take that 20%, we're going to change it to a decimal, and then we're going to multiply that by whatever we're taking it of. Okay, so 20%, we change that to a decimal, moving over the decimal 2 places. That's the same thing as 0.2 or 0.20, right? That 0 at the end isn't really doing anything. 0.20 times what we're taking a percent of, in this case, 50. Okay, so 0.20 times 50. Again, we can use our calculator if we need to. 0.2, 0.20, same thing, times 50. We get 10. Try to use some common sense as you're doing these, right? 20% of 50, well, that would make sense if it was just 10. Okay, if you got a number like 100, well, that would be problematic, right? Percent should be, if it's less than 100%, it should be less than your original number. Okay, we tried 30% of 45. Well, our decimal's at the end, move it over 2 places. It's the same thing as 0.30 times, in this case, 45. Okay, and then we can see what we get. 0.3 times 45. It's 13.5. Okay. 3 says 5% of x. Well, x is a variable. This one we're just going to be writing out a small little expression. Let's first change that 5% to a decimal. We move it over 2 places. Well, notice now we're going to have a 0 in here, right? 5% written as a decimal would be 0.05 times x. Well, that's the same thing as just saying, normally when we have a variable next to a number like that with multiplication, we just write it like this, 0.05x. Notice we can't multiply those together because we don't know what x is, right? We couldn't simplify that any further because we don't know the number that x is representing. It's a variable. Okay. For 80% of 8, well, same process. We're going to take our decimal point at the end, move it over 2. That's the same as 0.80 of 8. See what we get. 0.8. This one you can probably do without a calculator. Times 8. That's the same as 8 times 8. Move the decimal 1 place. 6.4. Okay. From here, why don't you guys do 5, 6, 7, and 8? We're actually going to talk about this beginning of class next time. So we'll look at the answers to those when we discuss this in class. Let's go to our next problems. Okay, so now it says write algebraic expressions for the final price of each of the following. By the way, we flipped over to the back side of this worksheet for the second page if you're doing this on the PDF. It says let X represent the list price of the item. Okay, so it's saying X represents the list price. That's what we don't know. Okay, so if we look at number 1, it says we have a 15% discount on the list price. So we're trying to write an expression that represents the final price, what we actually paid. Okay, for problems like this, we always have to start with that list price. Okay, and the list price again is just X. So let's start by writing out our X. So if our expression just said X, that is representing the list price. Now we need to manipulate that list price in whatever it says. Okay, so it's saying we want to take that list price and then do a 15% discount on it. Well, a 15% discount, that's saying we're going to take away, subtract off 15%. Well, that's the same thing as 0.15. So we're going to subtract, because it's a discount, 0.15, but we're not going to stop here. Because currently, if we just left our expression like this, it would be saying, okay, we have our list price, and then we're just taking off 15 cents. That's not what we want. We want to take off 15% of X, our list price. So it would be X minus 0.15 X, because percents are always of something. So if you're ever taking a percent and just writing it by itself with nothing attached, that's wrong. Okay, we got to take 15% of something. That's why we did the front side of this. Okay, now guys, this isn't fully simplified. Hopefully we're seeing that. These are like terms, X and negative 0.15X. Okay, so this is really saying 1X, right? That's really the number in front. So if we were going to combine these like terms, we would just do 1 minus 0.15. Well, that would make 0.85X. So that would be our simplified expression, 0.85X. Okay, let's try another one. Look at 2. It says a 12% shipping fee on top of that list price. Okay, so it's saying take our list price and add on a 12% shipping fee. Well, we got to start with the list price. Okay, so the list price again is just X. Okay, so currently we have our list price. Now we want to add on 12% to that. So plus, remember, 12%, that's the same thing as 0.12. Okay, so we have X plus 0.12. And remember, anytime we're taking a percent, it's of something. So 12% of that list price, X. So you have X plus 0.12X. Well, again, like number 1, those are like terms. This is really a 1X plus a 0.12X. Well, 1 plus 0.12, that's 1.12X. Okay. That would be our simplified expression. 3, try another one. So an 8% discount on the list price. This one's pretty similar to number 1. So why don't you guys try to do this one on your own right now, and then we'll check in. All right, so 8%. Check this step carefully. Move the decimal 2 places. You should have changed that to 0.08. We would guess that would be where any mistakes would happen most likely. Okay, so now we start with our list price, which again is X. Oops, sorry about that. X. Now we want to take a discount off of X. So discounts we subtract off from that list price. X minus, again, we changed that 8% to 0.08, 8% of X. X minus 0.08X. Let's simplify. Okay, this is the same thing as a 1x. So 1x minus 0.08x, that would make 0.92x. All right, more complicated one. So now putting it all together. Okay, so it says we have a 10% discount and a 7% sales tax on our original list price, plus a $5 shipping. Okay, that just ramped up pretty quick. Okay, so we got to start with our original list price. Okay, so we're going to start with our X. Okay, so that's what it was originally costing. Next, let's just take this piece by piece. So we want a 10% discount. Okay, so 10% discount, we can change that 10% to a decimal, 0.10. Okay, so reminder, discounts we take off from our original list price. We put minus 0.10x. Subtracted off 10% of x. Then we have a 7% tax. Sales tax. Remember, taxes are always added on, right? You're paying more because of taxes being added on to that original list price. Okay, so 7%, 0.07. Okay, if we're changing that to a decimal, we're going to add that on. So plus 0.07x. And we're taking this percentage of that original list price. Okay. So if we read this so far, if we just read our expression aloud, we have X, which was our original list price. We subtracted off 10% of X. That's our 10% discount. Then we added on 7% of X. Last thing, it says plus a $5 shipping fee. Okay, so this is not a percent, right? This is just saying add on $5 to your total cost. This is just going to be a number at the end, plus 5. Plus, because it's added on, right? You would add on $5 to your cost for there to be a shipping fee. Last step, let's simplify. Okay, so we have really 1x minus 0.10x plus 0.07x. Be careful when we put this in. So we do 1 minus 0.1 plus 0.07, 0.97. So our final answer, 0.97x. Then don't forget the plus 5 at the end. Notice we didn't add that on because that's not a like term. Right? 5 and 0.97x are not like terms. Tough lesson, and this is what we're going to continue doing tomorrow. So this is just our introduction. So what we're going to ask is that now you guys complete 5, 6, and 7 on here as well. And we will go over these problems tomorrow in class.